guess the alternative to energy efficiency would be to meet load with building new power plants, new transmission, things like that. So by investing in more efficient operations, we're reducing the need for those things. Also, it reduces carbon emissions because we're not generating as much electricity, and it can improve comfort levels and, of course, creates a beautiful, sustainable energy future. These are our service territories, electric and natural gas. That's kind of a bad slide, that size, isn't it? But most of the Portland area, Willamette Valley, about 70% of the electric customers in the state, and I think a little bit higher of the natural gas customers, about 80 to 85% of the natural gas customers. The rest of it is served by generally public utility districts, BPA, and then a little bit in Eastern Oregon of Idaho Power. So they have incentives too, and I know a little bit about them. I think Lizzie maybe knows a little bit about them too. So if you do happen to have some facilities outside of any of these territories, we can try to get you in touch with the proper people to help you out. So industry and agriculture, that's the group I work in. It's manufacturers, it's big industrials from the high techs in Hillsboro to a little metal shop somewhere in Portland. Agriculture, nurseries. I put wineries under agriculture, but it's kind of that fine line between manufacturing, processing, and agriculture, because you're doing a little bit of both often. Dairies, irrigators, and then we also have wastewater treatment facilities. I think some wineries even have wastewater treatment issues too. So that's kind of the folks that we serve. So I'm going to talk about energy efficiency opportunities. When I first got into the energy world about 5 years ago, someone told me that you have to eat your efficiency vegetables before you can get onto your renewables dessert. And so I guess that's kind of what we're doing here. We're shoving the efficiency stuff down your throat before you get to the fun solar stuff with Lizzie. So I'm going to give you guys an example of a lighting project that I kind of cobbled together. Oops, that's not it. I'm calling it Wilson's Winery, and I gave myself the title of Cellar Master because I thought it kind of sounded cool. But I'm going to show you an example of the actual project and the incentives available and kind of how the savings happen, but then also show you kind of some additional technology-based things. So, over here we've got some different locations. We've got a tank room. You see that okay? Yeah, okay. We've got tank room, office, an event room, bathroom, barrel room, office 2, and over here is kind of your existing case. So T12 lighting, it's kind of the old standard fluorescent lighting. It's the T in T stands for tube, and then the number after it is in 1/8 of an inch, the size. So that's a 1.5 inch tube. It's the biggest one, and because you're trying to get all the molecules running through there and getting excited with the electricity, it takes the most energy to get going. So. Kind of a standard retrofit for a T12. If you look over here, it would be a T8 lighting, so that's a 1-inch tube, and the watts per fixture for a T12 is 138. The watts per fixture for a T8 4-lamp fixture would be 95. So to go from watts, the watts of a fixture to watts actually consumed, it's a fairly simple calculation that I don't necessarily want to go through with you guys, but it's just watts multiplied by hours, and then you get kilowatt hours, which fall over here. So the T12 system was consuming about 1,800 kilowatt hours. The T8 system for the 4 fixtures is about 1,200 kilowatt hours, and you're saving almost 600. So we've got standard incentives and some custom incentives down here. I don't want to go through each line by line, because I don't think that would be a very exciting presentation, but generally speaking, we've got a way to offer incentives for almost any kind of lighting system that you want to upgrade. This room right here, these are all T8s. They're a direct indirect fixture, so it kind of throws some light down and then some light ambiently, and there's just a lot of different options out there, which is really nice. You can figure out what's the best option for your facility, your bathroom, your event room in this case, your barrel rooms. We've got high bay incentives. I'm going to bring you down to line 23 here just to highlight that. An old metal halide, and I have some pictures later to help explain exactly what this means, but an old metal halide fixture you know, we could go to a T5, which is an even skinnier tube. It'll put out a lot of light, and you don't necessarily want it right down in your work plane because it can be a little bit abrasive on the eyes. But in a high bay, in a warehouse facility or something like that, it can be a very good option, and it consumes very little electricity in the long run. And you can see that's actually the line that's saving the most electricity because it's 17 fixtures in the, I think, what do we call it, the barrel room. Oops. Anyway, I also added some controls to this project. In the tank room, we're putting a control on each fixture. So as you're walking around, each fixture could turn on or off. If you come into one corner of the room, that fixture would just pop on. And if you walk through the whole place and you need the whole place lit up, they'll all come on. The way most occupancy sensors work is you can set them for on time and off time. Generally speaking, it's about 15 minutes, but some people have them shutting off in 5 or fewer minutes. Another one for an office is kind of a ceiling or wall occupancy sensor. I don't see one in here, but those would be kind of in the corner and would turn all the lights on in a room, because a room like this, you'd probably want them either all on or off. And down in the barrel room, we did the fixture again. And then in a bathroom, something pretty small, we did a switch occupancy sensor. And each of those have different incentive levels ranging from $25 to $100, depending on kind of how many fixtures we would expect them to control. And we generally assume about 25% energy savings by adding an occupancy sensor. But if it's a space that's not occupied very often, we could bump that up, and you'd get either a higher incentive or definitely more energy savings in the actual functioning of the project. So I'm going to jump over to kind of the estimates of the project. So estimated annual energy savings are about $25,000 a year, a little over. So at this rate schedule, they're paying about, I think, 7 cents a kilowatt hour. So almost $2,000 a year they're going to save just from the energy savings. Energy Trust for this project is willing to put almost $3,200 towards it to buy down the original cost, and the estimated installation cost was $7,300. So the economics come down to about a simple payback of 2.2 years or an ROI of 46. I know that's kind of not the standard ROI most people think of, but pretty good payback for lighting projects. They tend to be one of the most cost-effective and quickest ways to get started on the energy efficiency front. So here's another slide of just some comparison. T12 HO is a common, that's high output for those of you, is a common high bay old application, and if the existing wattage was 219, you could upgrade to a T8 high performance, which was 108 wattage, and you'd save 372 kilowatt hours. We're assuming the same hours of operation as that last project. Another option for T12 HO is the T5. That's the second line there that I mentioned. Metal halide, that's down here at the bottom. These guys, they're pretty common. You can also see some metal halides on the outside, which look a little different. They're kind of like square on the wall, but that's a common replacement for a T5 HO, and you'll get probably a little bit more light by going to a T5, and the the light degradation will be much less than a metal halide. A lot of us have walked into old warehouses where the light's starting to turn kind of more orange and not as enjoyable to be in. I also put LED on here. LED is obviously kind of the new cool thing everyone's talking about today. And that, if you look down the kilowatt hour saved list, that shows, over 1,000 kilowatt hours saved, and it seems like, wow, that's definitely the way to go. However, the cost of the LED fixture at this point is going to be 3 or 4 times that of a T5 HO. But they are coming down rapidly. I think in the next couple of years it's going to be the thing to do, but right now we're still encouraging people to go with the T5. It's probably the best investment for their money. And that last line, just kind of a T12 to T8, that's kind of your standard office lighting upgrade. And I threw this slide in here in the middle, or the picture, that's the T12 1.5 inch, T8 1 inch, T5 5/8 of an inch. Just just kind of shows you how skinny they get. You know, if you're ever at Home Depot or something, they have both T8 and actually they even have some T12, believe it or not, even though they're not manufacturing anymore. But T8 and T5s on the wall, and those are kind of neat to look at, and you can definitely see the different colors and functionality of those products. All right, so I'm going to jump on to a compressed air project. I know some wineries use quite a bit of compressed air and some don't, so let me know if anyone has questions about this. But I'm just, you know, again, it's just kind of a standard information capture sheet where I'm, again, the cellar master because I think it sounds cool. But so I just put a fairly small compressor in here because we've seen a few wineries with compressors of this size. I know that many of you probably have much bigger, and so the scale would be a lot different. Also, the operation of this, I put 4 months of operating about 15 hours a day, and the rest of the year operating 8 to 10 hours a day, just because I thought that seemed like maybe an accurate load profile, but savings could be a lot different if your operation is different than that. So we're going from a screw inlet mod compressor, so it's modulating the amount of air it's letting in, to a screw VFD compressor. VFD is variable frequency drive. Another kind of funny story, when I got into the energy efficiency world about 5 years ago, people were talking about these VFDs and explaining to me what they did, and thought it had to be one of the coolest things I'd ever heard of. You know, I just couldn't wait to see one, and when I finally saw one, it's just a little electrical panel on the wall. It's, you know, running some wire out to a motor, and I was like, oh man, I thought it was going to be something a lot cooler than that, but oh well. So the VFD compressor, the idea of a VFD is it modulates the motor, it turns the motor down through, you know, some physics that I'm not going to get into again, but to match the load that's needed. So it's a control strategy that will ramp up and down the motors to match the actual load. So just some general, you know, existing case and the upgrade case, I just threw in kind of a guesstimate of cost. I've seen them come in lower than that and higher than that in a 15 horsepower range. I expect about $250 a year in maintenance if you have an older compressor. Oftentimes you're changing filters often, or, you know, repairing lots of different things. So I put that in there just to help it out. It's a common thing that we see. Another thing I did was lower the actual compressed air operating pressure, because we've seen a lot of times when people get new systems, they also will fix a lot of leaks in their system, and, you know, that makes them able to lower the operating pressure significantly. So here's kind of the profile of the baseline compressed air system. 5% of the time they were operating about 100% of the actual flow of the system. You know, 30% of the time they're at 65, 40% of the time 45, down to, you know, quarter of the time they're at 10%. I mean, this is an ideal situation for a VFD compressor. If you were running your compressor 100% of the time, all the time, you wouldn't need a VFD because you know, you're already operating at peak efficiency. But you can see that with the inlet modulation control, you know, the most turned down you can get is about 70%. That's this blue line here, and there are the operating points that you can see that I put in. But with the VFD, you can turn it down all the way to about 15%. And, you know, there's kind of some additional kW usage and whatnot here, as well as the actual kilowatt hours. But this, you know, this delta between the red and the blue lines, that's all the savings you're going to get by upgrading this system. And you can see, you know, up in the high range, if you're operating close to 100% all the time, there's really no need. But, you know, for variable operations, which almost any processor or manufacturer has, there's definitely a real need to, or a real opportunity to get some significant savings. An additional tab that I can show you is, or I will show you, is compressed air. In the compression of air, it creates water vapor, and then when it gets out into the system, oftentimes it'll condense and get into the pipes, and that can both hurt equipment and also corrode pipes. So oftentimes you'll need a dryer. Some compressors come with dryers installed, most of them don't, and most of the time you need a dryer post compressor before it actually gets out into your system. So We can also get this is a cycling air-cooled dryer, and the idea is you cool the air down, and so that by the time it gets into the system, it's not going to cool significantly and then condense and put moisture into your lines. So it's a similar idea here, where previously they were always running all out. In this one, because it can cycle on and off depending on demand, the dryer power draw is much lower. So I'm not going to get as far into that, but I'll go back to kind of our summary of results tab, and we've got site energy savings for the compressor, about 14,000 kilowatt hours a year. For the dryer, about a little over 2,000, and then there's a cooling fan that most compressors come with a VFD now, so that's not generally an upgrade, and we're not even going to go through the calculations there, but at about 7 cents per kilowatt hour, which again is just an estimate, it's about a 7-year payback, which is a longer payback, much longer than the lighting project, because lighting projects tend to be one of the best paybacks that we've seen out there as Energy Trust. But if your operation is different and you're running for more hours, or you're never hitting that 100% at all during the day of the total compressor capacity, you'd get better economics, certainly. And Energy Trust would put about $4,800 towards that project. A couple other things. This is our one winery specific measure. We did a study, I think some of the wineries in the room were involved in a while back, and this is the one that really came back from Ecos Consulting that did the study for us. It was wine tank insulation. This is a pretty small fermentation tank, but it's a good example of what Energy Trust thinks is a great way to insulate your fermentation tanks. You can see on here this bubble wrap insulation. It's covering the whole vertical surface of it, and you can see actually that there's a cooling jacket under there. From kind of there to there, you can kind of see where the cooling jacket is, and it's got all those dimples that most of the cooling jackets I've seen have. And we want the whole vertical surface covered, because if just this top area was not covered and we're only covering the cooling jacket, the difference in temperature between under the cooling jacket and out here would be even greater, and it would put more load on the chiller system. So we like the insulation with a reflective surface, R value of 4 or higher, and the total vertical surface of the tank. But it's 20 cents per square foot of insulation purchased. We assume there's going to be some waste, so we just go for the whole amount that you purchase. And our assumption through kind of averages of everything we've seen out there is that you'll save almost 1.5 kilowatt hours per square foot that you actually install. So obviously you're all going to be a little different because of your chiller efficiency and how big your tanks are and where you are and whatnot, but this is a measure that we're hoping gets picked up more. We've had some applications coming in. This is your standard rebate style, where you get the thing installed, send us a very simple 1-page form with the invoices, and then put a check in the mail. And here are just some other rebates out there. Radiant heating, if you want to heat your processing line, or there's people working on the packaging or bottling, depending on the efficiency of those, it's $6.50 to $10 per kBTU. Air conditioning systems, heat pumps, building installation we were talking about earlier. We have some very simple forms. Just kind of wanted to summarize these. There's also other incentives out there, but these seem to be the most relevant for either heating your offices, your tasting rooms, whatever it might be. So I'm going to step aside now. If anyone has questions before I do, we're going to be around afterwards too, but we're going to get to the fun stuff. The dessert, the Renewables dessert, and Lizzie's going to come up here.
That'll be the fun stuff.
Thanks, guys.
All right, so again, my name is Lizzie Rubidoux, and I manage the commercial side of our solar energy program at Energy Trust. A little bit about renewables and efficiency at Energy Trust. The vast majority of what Energy Trust does, where we spend our ratepayer funds that we receive, is in efficiency, because every facility has an opportunity for efficiency. It doesn't matter if you live where there's a lot of sun, or the wind blows, or you get geothermal resource, everybody can do efficiency. And in general, it's going to be the least cost, both from capital investments and how fast your simple payback is for most customers. So for that reason, 80% of the pie of what we do is around efficiency. But part of our goals with the entire organization is to also help transform the sources of energy in the state of Oregon, and that means investing in replacing conventional electricity generation with renewable energy generation. And so we do have renewable energy programs that work with projects, and we actually have a diverse array of incentive programs on the renewable side that match up with all of the resources that we have in Oregon, and Oregon is blessed with a lot of renewable resources. So we do solar, and that's our largest program because most number of customers are able to participate in solar, but we also have a small and mid-scale wind incentive program. We do low impact micro hydro, we do geothermal in the southern and central part of the state, and we also have a biopower program that works with everything from biogas from wastewater treatment facilities and landfills to dairy digesters to food processing projects. So we kind of do run the gauntlet of options that you have. The solar program and the small wind incentive programs are what we call standard incentive programs, which kind of similar to what Eric was talking about. We've structured it to make it easy, kind of user-friendly or user-friendlier. On the other technologies, like if you had a dairy digester project you were interested in, it's kind of a custom incentive project process where we crack open the financials on the project, we figure out how much energy it's going to save, we figure out how much money the project needs, and it's kind of a negotiation back and forth. But we try to make it easy because we have a lot of people who are interested in installing solar on the solar side. So I'm going to kind of walk through some high-level overview of the two solar technologies that Energy Trust provides incentives for, and kind of walk you through how we determine the energy savings you're going to get and what incentives are available. So a quick look kind of at the financials. So quick overview on solar electric technology or photovoltaics or PV. There's actually show of hands of folks who have solar at their facilities here. It's like half of you guys already have solar. I hope you're thinking of going bigger now. I'll convince you to go bigger. But basic overview, you have solar electric modules that are mounted on a roof. They're pole mounted, they're ground mounted. Those transform solar energy, photon energy, into usable energy that's actually DC, direct current. And that flows through an inverter, and the inverter transforms the electricity from DC to AC, usable flavor that you use in your facilities. And that AC output from the inverter is fed directly into the facility's main electrical panels or sub-panels, and then it goes out and serves any of the loads that you have that are tied to that electrical system. And if at any point your system is producing more electricity than your facility can use, which if you have a decent sized system and a nice sunny, cool day, that's very oftentimes the case here in the Willamette Valley, that you would be producing more electricity than you can use. That electricity actually flows through your meter back out onto the grid, and the utility takes measurements of that electricity, and you receive a credit on your bill. If during the course of a month you actually net excess produce during that month, they will kind of put it into a solar electric savings account at your utility, and you can then draw down from that account in future months like October, November, December, when your system is producing less electricity in a billing cycle than you've consumed. You can draw down, and we call that annualized net metering. So you have this opportunity to kind of treat the utility like a battery bank, which is awesome. We see virtually no batteries installed with solar electric systems. A lot of people think that in order to do solar you have to have batteries. That's absolutely not the case. You get to treat the grid like your battery bank. And right now the great thing is that they don't really charge you for that feature, and it's a one-for-one credit that you get from the utility. Every kilowatt hour that you feed out onto the grid, you get a kilowatt hour's worth of credit from it. So it's a great system. Not every state in the US has net metering available, so this is one of the great kind of policy features in the state of Oregon. Kind of quick vocabulary lesson on photovoltaics. If you look at a solar module, it's got all these sort of like squares, blue squares, black squares on it. Those individual squares we call photovoltaic cells. Those cells are wired up within the module in series parallel wiring into modules. You can also call them panels. And then when you wire together a number of panels or modules, either on your roof or in some other array configuration, it's called a solar electric array. So you'll have, people will talk about arrays, they'll talk about the number of modules that they have in their system, and then sometimes people talk about photovoltaic cells, not so much, mostly modules and arrays. The way in which the terminology, the units that we use when we talk about solar electric systems is in terms of the electricity producing capacity in watts or kilowatts, not to be confused with what that capacity produces in terms of energy, which is kilowatt hours. Kilowatt hours are what we ultimately really care about, because that's what you have to pay 10 cents pot for from the utility. So, you guys raise your hand. How big are the systems that you guys have? 20 kW?
10.
10 kW? Everybody else? Know what size their system is? So 20 kW, 10 kW, so 10 kilowatts, 20 kilowatts, which would also be 10,000 watts, 20,000 watts. And those systems, and I'll talk about how you kind of get from watts and kilowatts to kilowatt hours, which you actually care about. But here in the Willamette Valley, assuming that those systems are decently oriented, you're probably getting about 10,000 kilowatt hours or 20,000 kilowatt hours, maybe 21 or 22,000 kilowatt hours of useful energy over the course of a year from those systems. Quick geeky technology point. There's 3 different types of photovoltaic material that you can get your solar modules in. There's polycrystalline and monocrystalline, and these are kind of your standard process produced photovoltaics. They're grown as kind of crystal ingots, and those ingots get sliced into wafers, and those wafers get cut into cells, and those cells get wired up in modules. And that's kind of the original way that solar electric modules were made. There's also a product called thin film or amorphous silicon solar, and instead of growing giant crystals that you slice into wafers, they actually deposit the silicon material on a surface kind of like an inkjet printer, and they grow it up that way. And thin film, you can have it in a flexible product. So there's been companies that have made solar shingles that look like asphalt shingles. They're flexible. You can use these in membrane roof products, and I'll show some pictures of these. So they have given them, although actually the vast majority of amorphous thin film product actually just gets laminated behind glass and built into a module. So just because somebody says, oh, my system is thin film, doesn't necessarily mean they've got some like super cool, different looking, flexible product. They probably are most likely to have just modules that happen to be using thin film. Thin film is the cheapest product that you can get. It's the cheapest to manufacture, but it has the lowest efficiency per square foot. Polycrystalline is next, and monocrystalline is the highest efficiency. And so, cheaper per square foot, but less output per square foot. What it ends up meaning is that between these 3 products, from a price per unit of energy output per square foot, they're kind of comparable. And the reason you might go with a more efficient product like a monocrystalline that you're going to pay a premium for is because you're trying to maximize the energy generation out of a limited amount of space you have. Like you have a roof that is a certain size, and you want to get every kilowatt hour you can out of that roof space. And so you might go with a higher efficiency one. You might go with a lower efficiency, cheaper product because you just you got tons of space, no limit whatsoever. It's pretty inexpensive installation, so you're going to go with a cheaper product. And these are the sorts of things that a contractor and installer can advise you on based on your application, your situation, what are your goals around the project. So as I said, this is, PV modules or panels are kind of the building blocks of your system. Across the top, on the upper left-hand corner there, those are SolarWorld modules, which are pretty popular, manufactured here in Oregon, although there's several other manufacturers, including Sanyo, which is on the far right. That's their high-efficiency module. Those are also manufactured in Oregon. Both ones on the left and the right, those are monocrystalline. That guy in the middle there is a polycrystalline, and that's a thin film module. You know, there's not, you don't get like 20 different colors to choose from. They all kind of look more or less the same. They're about 3 feet by 5 feet, though there's some variations. Some kind of cool stuff that's out there. This module here is a bifacial module, so it doesn't have an opaque backing on it, so it can be installed in kind of awning or parking cover situations where you want to generate some electricity, but you also want some light, a natural light to come down through that system, so it can be really nice for kind of outdoor cover applications you might have on a patio or something. And then there's also, I mentioned solar shingles. The company that used to make the solar shingles that were kind of like asphalt shingles is no longer making that product, but there is a company that makes shingles that are designed to be part of like, you know, your Spanish style mission clay tiles, which are very common in Europe and in California, and so there's some very successful products that are designed to be directly integrated with systems, which are pretty cool. The other piece, you know, kind of component in a system that I mentioned is the inverter. This is really like the heart of the system. It's the single most expensive individual component you have in the system. It's really the only other thing going on aside from the modules. PV is very simple. And this is the system that not only transforms your DC to AC electricity, it has what's called maximum power point tracking technology, which is it makes sure that the system is performing as efficiently as possible. It cleans up the quality of the electricity so it matches the quality that you get from the grid. Sometimes it's even better than what you get from the grid, depending on where you are on the line on the grid. So these are pretty sophisticated pieces of electronics. The size of the inverter you need is directly proportional to the size of the array that you have. So if you have a 10 kW system, you guys probably have a single inverter that's about the size of one of those 3 guys that's up there in the corner. If you got a 20 kW system, you might have 2 of those, or you might have one that's a little bit larger. And as you get into bigger system sizes, multi-100 kW arrays, you're probably going to make a transition to a larger unit. If you're a mid-size, like a 40 kW, 50 kW, 60 kW system, you could go for a single larger unit, or you could have a series of smaller inverters. And again, there's pros and cons. A lot of it has to do with what's the most convenient configuration based on the amount of space that you have. But that's really it. Modules and inverters, and then a lot of expensive copper wire. So it's just some images to give you a sense of what this looks like. I've got photos from some of your colleagues. This is one of the earlier winery systems that we funded over at Solar Winery. That's almost a 50 kW system, and that's just conventional modules. Oh, are you here? Are you here? Oh, hey, awesome, nice system.
Yeah.
Now you know how big it is, 46 kW.
Yeah, that was 50. It's been a long time.
Yeah. So you guys, they have, you know, just modules that are installed. Do you guys have a standing seam metal roof on that building?
I believe so, yeah, recorded here. And we just built a new tasting room that also has an array on it.
Ooh.
And I think it's almost the same size, so that's in my notes to figure out combining how much.
Awesome, excellent.
Yeah.
So probably close to 100 kW, which is great. Love that system. This is not a vineyard or a winery, but it's a kind of application you might have some interest in at your facility. Parking covers can be a great opportunity if you want to create some shading, and that's an issue for your customers having their cars out there baking in the sun. Why not do double duty? And it's nice because these are pretty inexpensive. They're easy electrical installations because you have really easy access to the back of the modules to kind of hook everything up. It can kind of be low on the labor cost. And if you were thinking of doing some sort of covered array, that can be an opportunity. If you're thinking about putting in an electrical vehicle charging station, maybe, because you think it's cool, there's you can install solar with your EV charging point as well. There's a lot of neat opportunities. I mentioned the use of the Amorphis, the thin film stuff, in membrane roofs. This is one of a number of products that are designed to be directly fuse welded to a membrane roof surface. This is a good application when you've got really large warehouse type roofs. As I said, the efficiency of this stuff is about half, maybe less, in terms of the electricity output you get. And they're also, if you're installing them flat on a roof, they're pointing straight up, which is not an ideal tilt for solar modules. But again, because you got hundreds of thousands of square feet of this stuff, you kind of don't care, and it's a low cost way to go about it. There's some pros and cons, but we've got several megawatts of this stuff installed in Portland on warehouses. Sokelblosser. Susan Sokelblosser is gracing the covers of a lot of our marketing materials ever since we took these photos. But this is a nice small mid-sized pole mount array. I believe that this is a single axis tracker system, which means that they have motors in them which do draw a little bit of energy, but that energy is more than offset by the fact that you get increased electricity output because the modules track the sun as they move through the day. They probably also have manual tilt adjustments, so I don't think this one does that automatically, but you can go out and seasonally tilt them so that they're facing more directly up during the summertime when the sun angle is really high, and you can flatten them out or make them more vertical during the winter time. But great option if pole mount is going to make more sense for you. Ground mount, also an option here at Lemelson Vineyard, or there at Lemelson Vineyard in Carlton, a 50 kW array. So you've got a lot of different configuration options, and having property space at vineyards is probably not your limitation. So ground mount and pole mount can be a good option. The thing you want to keep in mind if you go back to your facility and you're thinking, where might be a good spot that we could do a pole mount or a ground mount system, is that you want to be in a good location that has good solar resource, no shading, but not too far away from a point of interconnection, because that's going to increase your trenching costs, increase the amount of DC wiring you have to run to the building, which is the big expensive copper wiring. And so getting it as close to your building but not so close that it's going to be in the way. So there's kind of a finding the perfect spot piece there. So just real quick on how do you get from 10 kW, 20 kW, 46 kW systems to the stuff you care about, the electricity generation. We use what are called local production capacities. There's a lot of ways you can do this math. If you've ever taken an intro PV class or cracked open a book or gone on a website, then you might have seen calculations involving the sun hours per day, 3.8 sun hours, and there's this longer equation. We've kind of simplified that, and we have on our website a table of local production capacities, which are a geographic specific unit of kilowatt hours per watt per year. So you can just take your capacity and multiply it by that number. And for here in the Willamette Valley, it's 1.14 kilowatt hours per watt. So for every watt that goes in, you get 1.14 kilowatt hours out of it each year. Of course, that's assuming an ideal system, and there's no such thing as an ideal system. Every system is slightly imperfect. So you generally derate the performance of your system based on things like maybe it's got a little bit of shading in the morning, or maybe it's not quite ideally oriented, like not quite due south. It's a little bit east to south or west of south, or maybe it's not at 32 degrees tilt, maybe it's at 28. And so all of those things kind of shave a little bit off. So you multiply it by some factor that's less than 100%. And this is that percentage number is what a solar contractor figures out when they come out with their solar pathfinder tool or their fancy camera device, and they take some measurements on your property and they tell you how much shading you have at the sites they're looking at. They're kind of figuring out that percentage number. And in order to qualify for energy trust incentives, that number needs to be greater than 75%. So we understand that not all sites are perfect, but we don't want to pay for bad solar. And that works definitely for commercial applications. That's usually not a barrier. So essentially you multiply your watts by that unit for your geographic location by some value less than 100%, and that is how you get to kilowatt hours of production per year. And if you want to know how much that saves you in utility costs, you just multiply that by your fully loaded utility cost, 10 cents a kilowatt hour, 9 cents a kilowatt hour. And that gets you the energy benefit of that system on an annual basis. A good rule of thumb, if you're interested in square feet, like how do you get from watts to square feet, is it takes about 100 square feet of space for a roof-mounted array to get a kW of solar, 1,000 watts on your roof. So this 5,000 square foot system would be about 50,000 watts. And it's a little bit, that number is a little different if you're going to do a ground-mounted system, because you kind of have to space your rows out so they don't shade one another. But that's a good rule of thumb. So the 20-year net present value of that energy generation, and 20 years, you're like, whoa, we don't look at anything on 20 years probably, but we do at Energy Trust because this technology is actually has a performance warranty, not a it won't die by warranty, but a performance warranty where the modules will not produce less than 80% of their originally rated output by year 20. The actual equipment warranty, I don't even know how long it is on modules, like 40, 50 years. So the realistic life expectancy for solar electric modules is long. The first PV module that was manufactured by Bell Laboratories in 1954 is still churning out electricity at the National Renewable Energy Lab. So we actually don't know what the end date is. They do get less effective over time, but they continue to produce electricity. But $70,000 at a 6.6% discount rate, so not bad. In terms of the incentives and the cost of the system, Energy Trust incentives, they vary by utility, and actually right now they're in flux for solar electric systems. We're in the process of increasing our incentives for commercial PV systems. So this $1 a watt figure I used may or may not be exactly what it would be for this system, but it's in the ballpark. So you would get $50,000 for this 50 kW solar electric system. There's also a federal tax credit for solar electric systems that all of these projects, all of you guys that raise your hand, you guys probably claim that tax credit because it's substantial. It's worth 30% of the cost to install your system. So 100,000, and it's a tax credit, not a deduction, so it's worth dollar for dollar, can be applied against any tax liability that your facility has. Then there's also accelerated depreciation schedule for solar electric equipment that gets depreciated on an advanced 5-year schedule. And for systems that are installed in 2013, there's a bonus 50% depreciation in year 1. That ends up being substantial. It's usually, if you do depreciation-based accounting, and I'm guessing all of your facilities do because you have so much equipment, that can be worth 10 to 15% of the cost of the project. So between the federal tax credit, Energy Trust incentive, accelerated depreciation, that can cover 75% of the cost of the project. So in this example, this installation might have cost $190,000. It drops to $70,000 after you factor in all of the incentives that you get, and that's about a 7.5-year payback. If you get a slightly better price, less complex installation, you might be down at 6.5 years. If it's more complex installation, more expensive, you could be up around 8, 9, 10 years. So real quickly, I'm going to walk through solar water heating, which is the underappreciated stepsister of solar technology. Actually, solar water heating has been around a heck of a lot longer than solar electric technology has been. I mean, if you want to heat water in most parts of China, the only way that you do it is if you cobble together your own solar water heating system. So it's a pretty kind of basic, fundamental, low-tech technology, but it's really been eclipsed in the last 10 years by the growth and explosion of adoption of solar electric technology. And the reality, as you're going to see with the numbers, is that the price of photovoltaics has come down so much, and there are better incentives for solar electric systems in general than there are for solar water heating systems. As a result, you're getting to, we passed the point actually last year where solar electric systems are now generally cheaper on an energy benefit, how much energy benefit you get for your upfront investment than solar water heating systems, which is, for solar dorks, kind of a crazy thing because solar water heating systems are more efficient at converting solar energy into useful energy on the back end. So, people who've been in the solar business for a long time kind of bemoan the fact that, gosh, solar water heating, it makes so much sense, but how do we get more people to do it? So, we do provide incentives for these systems, and we have projects going that are great. Basic mechanics, you have the kind of, the diagrams kind of look the same. You've got rectangular things that go on the roof. In this case, they're collectors as opposed to modules. And these collectors they're a little bit larger. They're usually like 4 by 7 feet, 4 by 6 feet, so they're larger. And inside, they either have kind of serpentine tubes running in them, like a long snake, or they might have more of a manifold type thing with a top bar, a lower bar, and then pipes in between that contain some sort of circulating fluid, usually an antifreeze blend. In Oregon, we do not use open loop systems where you're throwing potable water up on the roof, because that would be a terrible idea anywhere in Oregon. So you see those down in Southern California, and they're wicked cheap, but alas, we don't have those here. So usually some sort of circulating fluid, and that fluid gets pumped up to the roof, gains a bunch of delta T, a bunch of heat up there, it comes down, and you've got a heat exchanger in what we call the solar preheat tank. And that heat exchanger transfers the heat gathered on the roof into the potable water that's inside that tank, and that is like your solar water, your solar hot water. And it can bump all the way up to 130, 140, 150 degrees on a nice, bright, sunny day. If you have load that you're drawing on it, you can get a lot of energy output out of these things. That preheat tank needs to have some sort of backup heating system, though. It could be a backup tank system. You can do combined tank system where there's just an electric heating element at the top of the tank. Maybe you've got a tankless unit as your backup. But the preheated water flows out of your preheat tank and into whatever your backup water heating source is. And that way, on a day like today, maybe in the morning where it hasn't had a lot of time to operate, if you need hot water at 145 degrees, you've got it. So maybe the preheated water is up at 70 degrees, and your backup source is going to kick in the additional 70 degrees that you need to get it to your set point. On a hot summer day or a bright summer day, the backup water heater source is not going to come on. It's just going to flow through. And then it goes to your hot water loads. Again, as I said, you get stuff on the roof and stuff in the utility room, so kind of from a black box perspective, these things look similar. Basic differences in your collectors. There's a slightly different technology called evacuated tube collectors, which I would say probably about 50% of the projects that go in use evacuated tubes. It's the same basic idea. It's a circulating fluid. They're vacuum tubes. There's some benefits to them, and there's some drawbacks. And a lot of them are manufactured in China, so most of the Chinese solar water heating systems use evacuated tubes, and we're seeing a lot of imports into the US. So they've come down in price a little bit. The kind of conventional ones that you've probably seen before are flat plate collectors. And these can be oriented in kind of portrait mode or landscape mode, and sometimes they're pumps that they have to circulate the fluid. They even have a little PV module up there because you only need to circulate the fluid when the sun is out, right? Because that's the only time when you can gain some solar resource, so they're kind of a natural fit. You also have your backup tank. The size of the tank you need depends on the number of collectors you have. So, you can go anywhere from large custom tanks to small kind of residential sized tanks. And then just, this is a large solar thermal system at a hotel and spa in Newburgh. This is one for a process heat at Lucky Lab Brewery. They use it for their brewery process. So we have, customers who are using it for kind of industrial type purposes. This is a very large system on Bug Clark Commons, which is a low-income housing project in downtown Portland. So a variety of projects. The way that you get to determining how, it's a little more complicated to figure out how much energy a solar water heating system is producing, and you use modeling software to do that. I guess you could do it longhand, but we don't. If you're interested in playing around with this, there's a piece of free software you can download called RETScreen that the Canadian government puts out. It's awesome. It gets updated all the time. It's kind of like what most people in the industry use, though there's a bunch of more expensive versions that you can buy if you want to, but we use RETScreen. It's Excel-based. Read through the FAQ on how to use it and jump in. What it's going to do is it asks you some basic information about the kind of system you have, where it's located. You kind of load in weather data based on your location. Of course, it all starts out for Canadian provinces, and you have to change everything to like US units. But what you end up doing is kind of building up the load for your base case. So you say how much hot water is your facility using in gallons per day, or you can choose the kind of facility it is, and it has some kind of ASHRAE type assumptions that are built in there about gallons per day of hot water. What sort of temperature do you want? What would be the tilt and orientation of the collectors? Blah, blah, blah. And at the end, it spits out a comparison between base case being if you just heat your water today, how much energy does it take for you to get that water hot like you want it? And then proposed case being if you incorporate the solar water heating system that you just pulled in the figures for. And the difference in energy consumption of those two values is how much contribution you're getting from solar. So in this case, it was like, almost 88 megawatt hours in the base case without solar, and it's 59 megawatt hours per year with solar water heating. And so your savings because of the solar system is almost 29 megawatt hours a year. And so for our solar water heating incentives, it's based on these estimated savings values. The actual incentive varies by fuel type, but essentially you take that savings, you multiply it by the current incentive, and that's what you get from Energy Trust. The same federal tax credit and accelerated depreciation apply, so big contributors to the financials of the product. Usually, if the incentives, total incentive package you're going to get is going to cover about 50% of the cost of the project. So a $40,000 installation dropped to $21,000, but we're looking at a 3.5-year payback. So in this case, with this project, which had pretty high hot water loads, the higher the hot water loads you have, the better the payback is going to look like. The more hot water, the problem is that solar water heating systems often get installed at sites that don't actually use that much hot water, so they don't have an opportunity to do their job. The more hot water you're using, the more productive it's going to be. So some things to ask yourself if you're thinking about solar. First question is solar the right fit for your company, for your business, right? Why are you interested in solar? So reasons that you might look at solar, you're interested in making a visible commitment to sustainability. That's one of the awesome things about solar is it's like something you wear on the outside. People can see the modules when they come to your tasting room. They can see them in your photos on your website, unlike insulation on the walls or a VFD on the wall, as cool as that might be. Hedging against variable utility costs. You're in control of that portion of your energy resource. You grow it on your site. You harvest it on your site. And so, energy costs could go up, and the portion of energy that comes from that source is not affected. If you have an interest in being more energy independent, it's another reason to consider solar. And if you're interested in internal rates of return on some capital that you might invest that are going to bring you anywhere from 8 to 20%, that's another reason you might do it. Then you have to ask yourself, okay, is our business situation a good fit for making an investment in solar? So is a payback of somewhere in the ballpark of potentially 6 to 9 years acceptable? Or does your company have a threshold that's lower than that for investments? Do you have access to capital or financing to make a $50,000 or $100,000 investment? The cost of these systems is completely variable, right? They're like Legos. Plug them together. You can do 10 kW, 20 kW, 50 kW, and the price is pretty linearly variable as well. But if you're going to go the Energy Trust route, you have to make an upfront investment in that project to make it go. Accordingly, you also want to ask yourself, do we have federal income tax liability at our company? Have we made any money recently? Are we paying taxes? Do we have so many credits from other sources that we don't actually end up having much tax liability? Because if you're not able to monetize that federal tax credit, you're going to have a big hole in your economic equation. And if the answer to any of the three above is no, you have another option, which is third-party ownership. And I don't know, are any of the systems, to your knowledge, that you guys have owned by a party other than your company? Well, this is a fairly common financial model that's used by companies that are installing solar or businesses installing solar, which is where a third party pays for the installation, owns it, operates it, and maintains it under some contract with your site. And you guys receive the energy benefit, and you have either a lease payment or you're essentially paying that third party for the energy at some rate that's usually lower than your current utility rate. So you get the benefit of solar on your roof, a little bit of energy bill savings from the system. You get to have green power, but you don't own it. So you don't receive the incentives and tax credits, but you also don't have to operate and maintain it or pay to install it.
And so that opens the door, and I know we're starting to get close to the end time, but that does open the door to talk about how you record your solar on your greenhouse gas inventory.
Sure. So does the term renewable energy certificates mean anything to folks in here? No? Yes? So I think everybody understands that when you install a renewable energy source, you're generating green power, right? And that's kind of the general agreed upon renewable energy sources are better than the conventional alternative, and everybody in Oregon agrees that that's the case. And the issue when renewable energy kind of technologies were first being deployed in the country was, well, how do we account for the difference between the fact that a coal plant is a coal plant and a wind plant is a wind plant and a solar module is a solar module? There's an inherent difference to that, but how do we measure it? I mean, the output is the same, right? It's all electrons. So what was decided along, I think the market for renewable energy certificates was created about 15 years ago, was that, well, when you install a solar system, you're generating not just electricity, you're generating environmental benefit for everybody. Cleaner air and water, all those other benefits that Eric talked about at the beginning of the presentation. And those have an actual value, a monetary value. But that value might vary based on the fact that in the future there might be carbon cap and trade or other markets. And so what we're going to do is say that renewable energy sources actually produce two products. They produce electricity and they produce environmental attributes, which is the legal term for them. And those environmental attributes we're going to kind of certify in the form of renewable energy certificates, also called green tags, also referred to as RECs. And those renewable energy certificates are the quantification of those environmental attributes, some of which are reduced carbon production, but there's also other stuff that it's other benefits included in that, in the form of reduced water pollutants and other air pollutants that are not just carbon. And so anybody who installs a solar electric system or a small wind turbine, their system is not just producing the electricity they use, it's producing these renewable energy certificates. And these renewable energy certificates can be used as documentation of your reduced carbon output at your facility. One of the things that complicates this is that under certain circumstances, in order for renewable energy certificates to be kind of legally binding, they have to be registered. And they have to be registered in the West, we have a system called REGIS, W-R-E-G-I-S, which is the Western Regional Energy Generation Information System, I believe. And that means that the generation from your system has to be kind of tracked, and the number of renewable energy certificates that are being produced along with the electricity has to be tracked in the system, so that if you sell your renewable energy certificates to your next door neighbor, say, hey, I'll sell you my greenness for a penny a kilowatt hour, so you can call your facility green, but that gets tracked. And it's not like you can't be calling yourself green if you've sold the greenness of your electricity to your next door neighbor. So it's to make sure that we're not double dipping and that this secondary commodity market is being appropriately regulated. The other thing to know about RECs is that when you receive incentives from Energy Trust, or we were having a conversation earlier about there's another incentive source in the state of Oregon, it's called the feed-in tariff pilot. If you receive incentives from the feed-in tariff pilot, like another utility source, oftentimes there's some strings attached to those incentives that involve transferring a portion or all of the renewable energy certificates from your project to that incentive provider. So with Energy Trust, when you receive an incentive from us, you get to claim the first 5 years of your RECs, and then the next 15 years of your RECs get claimed by Energy Trust, who retires them on behalf of the ratepayers in either PGE or Pacific Power, whichever utility you are. And then after year 20, they go back to you. For the feed-in tariff, they claim 100% of the RECs go to PGE or Pacific Power, whoever your utility was. What that means, the reason that you should care, I just said a bunch of junk that, whatever, is that if you if the goal of installing a solar energy system at your site, a solar electric system, is to be able to make carbon claims at your facility, it's important that you know whether or not you own these RECs, these green tags, during the time you're making your claims. The reason that Energy Trust we have to take ownership of a certain percentage of the tag as part of our regulatory requirements. The reason you get the first 5 years and we take 6 through 20 is because we know that when you install a system, you want to do a lot of marketing about your system, get it out there that you're green power, you're bottling your wine with 100% renewable energy, or whatever it is that you want to say, and we want you to make those claims. We don't want to compromise your ability to make those statements at all. So we give you the first 5 years to put that out there as much as you want. And then technically in years 6 through 20, you're no longer able to make claims like that, nor would you be able to say that you're producing carbon-free power from your solar system. So kind of important nuance. If you want to talk about that more or you have questions about it, I'm happy to get into it to the extent that I'm able to. Green tag stuff is pretty complicated, but it's certainly something to take into consideration. All right. Eric, you have this last.
Oh, sure. Yeah, I was just going to say, if you wanted to get started on any of these projects, most of these are what we call kind of trade ally driven projects, solar, lighting, the compressed air systems, where we have folks that we work with in the industry. And it's not, well, anyway, if you went to our website, we've got a whole list of trade allies that can install any of these kind of systems. They're well versed in our projects and our processes, and they'll contact us to access incentives. Lizzie and I, of course, are always available for questions, and we've got business cards and stuff. We were passing them out, but if you didn't get one, definitely grab them after, and we can help you through the process as well. But I guess my point here is we try to make it as quick and simple as possible by working directly with the people who can install the systems for you, so you're not having to talk to 3 people to get to access your incentives. And that's just a shot of our website, and up here there's a find a contractor link. I was going to take you there, but had a technical issue this morning. And then that was about it. So thanks a lot for coming. We know it's obviously an investment to send people off of the facility to come listen to Lizzie and I talk about our geekiness. So we're going to be around for a while, and
Yeah,
if you have questions for the group,
So,
it's been an honor.
before everyone leaves, I want to thank our speakers. That was an excellent presentation. Maybe I'm an energy geek as well, but I find this is the heart and the nuts and bolts of the energy program. This is where you're going to find the money, you're going to start to schedule and plan, and you're going to estimate how much money you can spend and how much further you can push. If you already have solar, if you already have hot water, where else can you go? If you already have done your lights, this is the place to go. I do want to thank the OVS, which is the sponsor. It's the lecture series, and I'll check out that bird later.
It flew away.
That's good. All right. Ending on a good note. I know that we're a little bit over time, but does anyone have questions for these guys? Do you know how to pick a contractor? For example, when you look on the website, there are so many contractors that partner with the Energy Trust, that know your incentives, that know how to combine all of this information, that will come on site and give these folks an idea of what the possibilities are through either solar or energy efficiency incentives. How do you pick?
My recommendation is always, get multiple bids. Everyone always says it, but people don't do it oftentimes. Get multiple bids and go with someone that you trust, and ask for references, certainly. And there are case studies out there. Energy Trust puts them out, and so if you go on our website and find some case studies, I think we've got some here. Usually it'll say who installed the system, and so you can get an idea of who's done something. Questions out here?
Yeah, I had a question, probably everybody else knows the answer, but I don't. What are the maintenance costs involved in these things? The modules and the inverters and any of the equipment that you have installed?
Yeah.
There's got to be some maintenance costs somehow.
No, of course not. It's absolutely perfect. For a solar electric system, there really isn't much in the way of an annual maintenance cost. I mean, you just saw everybody shake their head no. Have you guys done anything to your system since? Yeah.
Clean them every other month.
Yeah, clean them every once in a while. In the summertime, when it gets drier, especially because you guys have, our farm agricultural facilities, so you're stirring up dust on your property. Sometimes you want to spray them off in the summertime because they'll get a little bit dusty. During the winter, you don't have to worry about it because it generally rains frequently enough that they're self-cleaning. The inverter, the heart of the system, it is a piece of electronics, so it does have a life expectancy. Inverters are typically warranted for 10 to 15 years, depending on the manufacturer. The minimum requirement for our program is that they have to have a 10-year warranty. And you can expect that they're going to last about 10 or 15 years. So you want to plan into your long-term financial planning, and a contractor should do this. if you have one that is worth their salt, will include an inverter replacement in the kind of financial pro forma that they pull together on the project. But that's about it.
And I
Yeah.
think that's really important because some of you have heard this story before, but Michael Brown from Sokoblaster can tell you that he was in the carbon neutral challenge before it was the carbon reduction challenge. He was recording all of the data that was coming off of the panels and found out beyond the warranty that an inverter was bad. And so because he had been recording the data and he could prove that early on it was probably a faulty inverter, it wasn't putting out as much as energy as it should or just wasn't working properly, he was able to get a new inverter under the expired warranty. So there's definitely good reason to be monitoring and managing and recording your energy data.
And there are, along the lines of monitoring systems, and I don't, anybody who's here who has solar, can speak of if you know what you guys have at your site, but it's web-based monitoring is becoming almost standard feature, assuming that there is a readily available internet connection at the facility, which can be a really great feature if your site has a website and you want to kind of tout the fact that you have this system. You can display the daily, it's really cool. It's a little widget that you can put on your website showing the production from the system, the CO2 benefit, the number of trees planted, all those kinds of equivalencies people can look at today, this past week, this past month since it was installed. And it's pretty much standard practice, assuming that they can do that. So that's really cool. And if you're interested, you can also, for an additional $1,000, $2,000, if it's worth it to you and you have like a tasting room, and again, if you really want to tout this, you can get a little interactive, flat screen display kiosk that is in the entranceway that's talking about your system and can display the same sorts of information. These are standard packages that are, readily available with commercially installed systems.
So
Another one in the back.
I just a quick question. If I go to your website, specifically we're interested in right now some tank installation.
Okay.
Are there contractors that are listed there for that?
We haven't enrolled any, but I can send you some that I know I've done that. So.
That would be really helpful.
Sure. Okay.
Can, in terms of tank installation, is that something that we can just do?
Yeah, you could install it certainly.
So we can buy that. I know you can buy that reflective.
Yeah,
installation
yeah,
or
exactly.
whatever.
The average cost for the actual installation is 38 cents per square foot. We put 20, and then average cost of installation is 15 to 40, depending if you do it yourself or have someone do it.
do you have a good vendor for if these guys were to look online to find?
Yeah, we don't have any specifically enrolled in our program, so they wouldn't be on our website. But I'll send maybe you
Yeah,
and
and I'll-
whoever else I can send direct to. But yeah.
Can you speak a little bit to solar incentives coming forward? I mean, I've read a lot where they're talking about the federal government is kind of back and forth in terms of what they are going to be putting towards solar projects because they've had a few very...
Look into the
you know,
crystal ball. What is the future?
Well, I mean, in the
The
next
answer
40
is
years,
install
something
solar
like that.
today.
Yeah.
Who knows what tomorrow will bring? The incentives are great. That actually is the message. So what the future holds at the federal level, that federal investment tax credit, that 30% tax credit, is in place until 2016 for new installations. So you got a couple of years of comfort and security around that. I mean, granted, sequestration, who the heck knows? I guess they could rip it away tomorrow, but it's been a long-standing program. The expectation is that it will either be renewed as is, or it would revert back to its pre-Energy Act of 2005 rate, which was 10% prior to that. So, if you're thinking about it, now's a good time to think about it a little bit harder. There used to be a state tax credit. Several of the projects in this room probably received state tax credits for their system. They were very generous. Those no longer exist. It's a great example that, here today, gone tomorrow. Now, Energy Trust incentives, we plan to continue to offer cash incentives for these systems as long as they're needed. And the prices justify that. As I mentioned that we're looking at increasing our incentives right now. That's to help fill the gap that was left by the disappearance of the state tax credit that used to be available. Prices have come down dramatically on this equipment over the last 2 years, dramatically, but we've seen them kind of plateau now. So now that they've plateaued and flattened out a little bit, we feel comfortable that we can increase incentives to help fill that gap without the prices taking another nosedive and overpaying. So
When do you think those changes will take effect?
if I get my druthers by next month. That dollar a watt that I modeled in that financial example is not too far off from probably what it would be for that size system. But that's, if you're interested, shoot me an email. I can put you on the update list for when that announcement goes out about what those rates are. The reality is, though, if you're interested in enlarging a system, upgrading a system that you have, or putting a system in, solar contractors, all the stuff I told you, it's good for you to know. I mean, everybody likes to understand what it is that they're getting into, but this is like their bread and butter. And the kind of financial analysis, how all the incentives work together, that's really where the sales staff and kind of the bidding teams that work at these companies really excel. You don't have to necessarily understand exactly what the current rate is for the particular size system you're looking at, because they're going to bring that all together as a turnkey package solution. It's a very strong requirement of our Solar Trade Ally network, is that they do that for you, because we understand how much of a headache it is. Now, that doesn't mean that you don't have to talk to your accounting department and your tax accountants to make sure that it's going to apply to you. But in terms of what is the rate, what are the incentives that are currently available for your project, they will walk you through all of that. All of the incentive paperwork, they fill it all out and they walk you through it. You don't have to go digging around on the website for that, forms and things like that.
Has anything changed too from the standpoint of when we got ours put in, it was based on the lottery in terms of how, what size system you wanted to put in, and our provider at the time was saying that if you're looking at a 10 or less, your chances of getting that was greater than if you were going for a 20 or 30 or larger.
Yeah. So what's your name again?
Andreas.
Andreas. So what Andreas is referring to is there's another pilot incentive program in the state of Oregon that's called the Feed-in Tariff Pilot that will continue to run through about this time next year. And it's in lieu of an energy trust incentive. You can opt to participate in the Feed-in Tariff Pilot, which is actually directly administered by PGE and Pacific Power and Idaho Power. And instead of getting a cash incentive up front at the time you install your system, you get paid a premium for every kilowatt hour of electricity your system generates for the next 15 years. So it's kind of like, do you want an incentive up front, or do you want a premium payment? Do you want that incentive spread out over 15 years? And it's actually where the rates are currently and have been for the last 2 years of this pilot. It's been a better overall incentive package, more money paid out over 15 years than Energy Trust offers in an upfront incentive. So it's been very attractive for projects. They have very limited capacity. It's a pilot. They're testing the viability of the model. So they make funding available twice a year, once on April 1st and once on October 1st. And contractors or projects apply online with a very simple enrollment form during the enrollment window, which is it's now a 2-day enrollment window, so April 1st through 3rd and October 1st through 3rd. You submit your application with your system size and some basic information, then they close the window, and for projects that are 10 kW and under, they do a random lottery. And they say, of the people who applied, we're going to pick however many until we get to our allotment for this size, and then congratulations, you guys got reservations, and you can do projects. For projects that are between 10 kW and 100 kW in size, which is more typical of a size for a kind of facility like you guys have, it's a competitive basis. So it's what we call reverse auction, where you would submit an application and say, I need to get 18 cents a kilowatt hour from your incentive program. And everybody who's interested in an incentive bids in with that. And then they take the lowest offer and they calculate it up how much money that is, and then they go to the next lowest offer, calculate it up until they allocate the amount of funding they have for 10 to 100 kW. And so it's kind of a crapshoot. You don't really know, which is why your contractor advised you to do a little system and go the lottery basis, because you're more likely to get lucky on a random lottery than most projects are to be cheap enough to win the competitive one. And then above 100 kW, it's competitive and they just do it once a year. So nothing's really changed with that, aside from that the rates have come down since your system went in. Because every allocation period, if they get more applications than the amount of spaces they had for the allotment of the lottery, if that makes sense. Like they could fund 100 projects and they got 150 applications, that means they ratchet down the incentive rate by 5 to 10%, depending on how many applications they get. So every allocation, the rate goes down. So that program, it's continuing to be a fairly competitive lottery for the 10 kW and under, and a very competitive lottery for 10 to 100 kW. And you've got about 2 more rounds.